Dear ladies and gentlemen, colleagues and friends, my name is Igor Alexander and I have a PhD in nuclear physics as well as a passion for laser systems. Today I will take the chance to tell you a little bit about our new product line, which is aiming the 2 micron region and above. Monocrom was established in 1993 in a village close to Barcelona in Spain. We have a facility area of about 1,200 square meters, of which 1/3 is devoted to clean room facilities. Besides having the headquarters in Barcelona, we are also represented by different distributors all over the world. Our main activities are aiming to laser bars and laser bar-based technologies. Here we can offer wavelengths between 405 nanometers up to 2.3 micrometers, and we are planning to extend this region to 3 and even 6 micrometers, everything based on laser bars. For the moment, we can offer up to 250 watts CW and in QCW up to 1 kilowatt, which is wavelengths dependent and refers to 1 laser bar each. At the moment, we can achieve a bar-to-bar pitch of 0.4 millimeters, and in the future, we will reduce these to 0.2 millimeters for our conductively cooled stacks. In the lower section of the slide, you can see a summary of our fields of activities, and in this talk, we are mainly focusing on our high-power fiber-coupled diode laser modules. But before we dive into this section, I would like to take the chance and to tell you a little bit more about our mounting technology. Our mounting technology for laser bars is somehow different compared to what's common on the market. So we at Monocrom, we make sandwich structures, which are comprising 2 electrodes, which is shown on the lower right section of the slide. And in between of the electrodes, there lies the semiconductor. So what we are doing now is to clamp this structure, and while applying a force, we ensure good mechanically and electrical connection to the laser bar. And we do avoid using solder material. This allows us that we can mount our sandwich structures under room temperature conditions. Another effect is that due to the missing or the avoiding of solder paste and solder materials, we are insensitive to a coefficient of thermal expansion mismatch, meaning that there is no strict connection between the laser bar and the electrode. So the electrode still can release stress if it's heated up or cooled down due to current or environmental temperature changes. This has an advantage because we also can cool from both sides due to the sandwich structure. Both electrodes are made of copper, and so we can ensure that we have good thermal contacts and can extract the heat quite efficiently. Another effect is that due to the clamping, we do not have any smile, meaning, showing to an example on the lower left section of the slide, would be the left picture illustrates a soldered bar where you can see that the emitters are having a bowing. So due to the cooling down procedure in soldering processes, you have a mismatch in the thermal expansion coefficients, which lead, unfortunately, to this kind of effect. Our laser bars, luckily, do not have solder material, so that the position of the emitters is mostly determined by the flatness of the electrodes. And these can be really flat. As you can see here, the variation of the emitter is less than 0.1 micrometer. And we can ensure this even for our stacks. Another advantage of our non-smile laser mounts and laser bars is that these are superb conditions, starting conditions for external resonators, which we are using in our high-power fiber-coupled diode laser modules, which I will explain now. So our AdFlex series are direct diode-based systems, which are using a combination technology, which is called rectified polarization beam combining. And this allows us that we can combine several laser bars while we will maintain the beam properties of one single laser bar, meaning that we have the spatial and spectral properties of one single laser bar while we are increasing the brightness in adding up 2, 4, or 8 times the power of the laser bars. So this enables us reaching up to 105 watts CW in the region of 2 to 3 micron. Since it's laser bar based, so semiconductor based systems, we can have pulsed conditions up to 50 microseconds, 10 kilohertz or more, depending on the electronics that you are using. And we also can operate the systems in CW. Due to the semiconductor materials and the electronics used, we can have a power tunability from 0 to 100%, and we can achieve wall plug efficiencies up to 10% in these wavelengths region. Besides the fact that we can deliver these systems fiber coupled, but we also can deliver these systems as free space versions. So if your application requires a certain degree of polarization, we would skip the fiber coupling and can restore the polarization orientation with our beam combining technology. So now you could ask, is this only restricted to the 2 to 3 micron region, or can I use this for every wavelength that Monocrom is offering? So our beam combining technology is wavelength agnostic, meaning that we can use this combination technology for every laser bar we are offering. So if you are aiming for, let's say, copper processing where you would need 405 or 445 nanometers, we can also mount these laser bars in our systems, reaching different power levels afterwards. So what's next? We are still improving the brightness of our systems, meaning spatial brightness when we are aiming to smaller fiber cores, but we also want to increase the spectral brightness while introducing filters inside our external resonator setup to narrow down the line width of the complete system, which could be advantageous when it comes to pumping applications. Besides that, we are also working on shrinking the dimensions and making it more efficient. Coming to the last section, which would be possible applications. So in the industrial sector, we figured out that the 2 to 3 micron region would be really good for polymer or plastic processing, meaning plastic welding, maybe also engraving and marking, as well as cutting applications. In the medicine, the field is a little bit more broad, so you could use these systems for cardiovascular surgeries, maybe also urology applications or refractive eye surgeries. But I'm sure that you know best which wavelength suits your application in a good way. So this was my talk, and I would thank you for the privilege of your time. And if you have any questions, drop me an email or give me a phone call. Thanks again. Bye.